Okay, so if you are on the accelerated schedule, like if you are in maybe 9th grade or so or above, you just probably finished section 6.1, so this should be the same day. Working on section 6.2. If you're not, if you're below 9th grade and you're doing the regular schedule, then 6.1 would have been all you need. All right, so let's look at section 6.2, which is on page 138 at the very bottom. Now, we're working with mixed numbers. Now, we've been doing, this past lesson we multiplied regular fractions. It's time to apply what we've learned about adding, subtracting, and multiplying fractions to mixed numbers. As we do, you'll see the same principles apply. Okay, at the very bottom, it says addition. Say we have 1 and 36 yards on one bolt and 2 9/36 on another. Can you guess how to add these numbers together? Top of page 139. If you said to add the whole numbers together and the fractions together, you were correct. That's one way to solve the problem. So there's your example. It's right in your book. I'm not going to put it on the screen. Solve 1 and 36 plus 2 and 9/36. Okay, by adding the whole numbers and the fractions together, add the whole numbers first, so you get 3. Then you add the fractions, and you can do it easily because they have the same denominator. So you get 39/36. But wait, there's more. 39/36 is an improper fraction, which means you need to change that to 1 and 3/36. Then you put all your results together. Remember you'd gotten 3 the first time from the whole numbers? Well, now you need to add the next part together. So it's 3 plus 1 and 3/36, which gives you 4 and 3/36, which reduces to 4 and 1/12. Now, instead, you could have converted both mixed numbers into improper fractions and then added them together. So 1 and 30/36 would convert to the improper fraction 66/36. And 2 and 9/36 would convert it to 81/36. We could then add those as fractions. Here's your example. So 1 and 30/36 plus 2 and 9/36 by converting to improper fractions first. 1 and 30/36 becomes 66/36, and there's 2 and 9/36, it becomes 81/36. Solve all that, you get 147/36. So then you simplify it. 147/36 becomes 4 and 3/36, but 3/36 can be simplified down to 4 and 1/12. Now, I know that kind of sounds like, whoa, what? But it's really easy. I kind of want to show it to you up here. I'm not real sure if you're following yet, but let's go ahead and do it just right quick, just to make sure you followed. So we're going to use the 1 and 30/36. Okay, now if you get this and you understand it, you can fast forward. I just want to make sure you do. If not, watch this. Okay, so then we're going to add 2 and 9/36. Now this is what we were doing from the page, from the sewing stuff. All right, we got to add all this together. So now the way that I prefer to do it, and I should have done it this way again, is I like to do it this way because my mind thinks better when I see fractions like this. Okay, I don't know why. Now, all right, we do not need to convert and change these because we're adding. Remember, they have to have the common denominators. They've got common denominators. Okay, always add the whole numbers first. Okay, so you get 3 whole numbers, 3 wholes, and then 30 and 9 gives you 39/36. Okay, but remember, this is improper, which means it's actually got a hole in it. Okay, so you can't leave it improper. All right, so what we're going to do is we're going to say, well, 36 goes into 39 how many whole times? 1 whole time. So you got to add that whole to this whole, which gives us the 4. With how many left over? 3. And of course, you always use the denominator. Okay, but wait, there's more. This can be simplified. Remember, if the fractions have anything in common where they can be squeezed down to their to their smallest number, we have to keep doing it. Now, there's not going to be any more whole numbers because we just keep that. So the 4 will just come over. Okay. Now, these can be both divided by 3, correct? So 3 divided by 3 would be 1, and this would be 12, and that's how they got their final answer. Now they're telling you that what you could have done is changed both of these to improper. Remember how to do that? 36 times 1 plus 30. Remember how to do that? And that gave them 66 over 36. All right. And then change this one. 36 times 2 plus 9. Remember that? And that would have given them 81 over 36. Okay. Since the denominators are the same, you just add across, which if you do your addition, it gives you then 147. Of course, you keep the denominators the same when you add. You don't add those. So then all you'd have to do is divide this, because this is just 147 divided by 36. That's all that is. Okay, so then you do your division, la, 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 la. You're going to get 4, and then there's the remainder would be 3 after you do all your blah, blah, blah. Of course, 36, you have to keep that. Remember how we made the remainder in a fraction? But then again, remember this is what we got right here, and then you'd have to simplify it down. Does that make sense? Yes, no, maybe so? I don't know. Hope so. All right, so somewhere I can get a new board. Right here. No, I don't want that. Let's just erase this. All right, so let's go forward. I think we're going to go ahead and move on to division, which is pretty easy. No, subtraction. Okay, subtraction. I'm sorry. All right, we're on page 139. When subtracting mixed numbers, it's helpful to rename mixed numbers as improper fractions in order to solve the problem. This will avoid confusion when the fractional quantity we're subtracting is greater than the fractional quantity we're subtracting from. Example, 1 1/3 minus 2/3. Notice that 2/3 is greater than 1/3, but not greater than 1 1/3. So convert those to improper fractions, and then you can easily subtract. So let's look up here. So we're going to do 1 1/3. We're just doing the one they had. Okay, minus 2/3. Remember, I always said I like to do it this way. They don't show it the way in this book, but my teachers always taught me this. So it just, to me, it makes it easier. Now, you can do 1 minus 0 would be 1, but you can't do 1 minus 2. You can rename and borrow, but I'm not going to go into that right now. It may have me do that here in just a minute. I'm not sure. So basically what we're going to do is we're going to change this into an improper fraction. So we're going to say 3 times 1 plus 1, which gives you 4/3, because remember 4/3 is the same as this. And then minus 2/3, keep that the same, and that gives us 2/3 as our answer. Okay, you can do it that way, and that will work. All right. Okay. So now let's look where it says example. Solve 2 1/3 minus 1 5/8. Okay, again, we're in the same boat. You can do 2 minus 1 for the whole numbers, but you can't do 1 minus 5. So what it's telling you to do here is make them both improper and see how that takes you. All right, so we're going to do 3 times 2 plus 1 gives you 7/3. Okay, and then we're going to do 8 times 1 plus 5, which will give you 13/8. I'm sorry. Yeah, 13/8. Okay, but we can't do this because remember it's subtraction, so we have to have common denominators. So our common denominator would be 24. That's about the only thing, the closest number you can get in common. Okay, so now we're going to change these to equivalent fractions with 24 on the bottom. Okay, so 3 times what gives you 24? 8. So whatever you do here, you got to do here, because remember it has to be 8 eighths, has to be the same number. that you multiply by. Okay, it has to equal 1. 7 times 8 then is 56. Okay, 8 times 3 gives us 24. So there again, it has to be a fraction that equals 1. It has to be the same top and bottom. So then 13 times 3 is 39. Ta-da! Now we can subtract. So 56 minus 39 gives you 17. And of course, again, we keep the denominator the same. And of course, that can't be simplified. 17 is prime, so you can't go any lower than that. All right, does that make any kind of sense? All right, look over at the next page, page 140. Erase all of this. There we go. Okay. Now, let's say we didn't quite want to double a cookie recipe. Instead, we wanted to make 1.5 batches. If the recipe calls for a 1/4 cup of sugar, we would need 1.5 times that quantity. We could write this as 1.5 times 1/4. What does this equal? Well, you may already know how to find the answer mathematically, but let's draw the problem out using pies as a visual to see what's really happening. All right, so you want to take 1/4, 1.5 times. This results in 3/8 of a whole. So there's 1 of 1/4. Okay, there's a half of 1/4. You add those together and you get 3/8. Say we wanted to quarter a recipe that used 1.5 cups of sugar. In this case, we want to find 1/4 or 1/4 of 1.5. What would that equal? Again, you're going to use pies. Notice that this time the pies have been cut into eighths, and there are 12 pieces in 1.5 pies. That's the shaded section. Say that fast 5 times. If we take 1/4 of those 12 pieces, we would have 3 pieces or 3/8 of a whole pie. So 1/4 of 1.5 equals 3/8. Now, to me, that kind of makes things a little bit confusing, but I can do it better on paper than turning it into a pie. They're just wanting you to see. I hope that y'all can understand, looking at these pies, how things come together and the reason why. Now, we're going to go ahead and just solve this problem. I'm at the top of page 141. I'm kind of skipping around a little bit. So we're going to go 1/4 times 1.5. Okay, this is if we're cooking. Okay, so what we're going to do first is we're going to convert the mixed number to an improper fraction. All right, so we're going to have 1/4 times, we already know that this is 3/2. Okay, then you just multiply across. Okay, 3/8. Ta-da! And this can't be simplified. That's as far as you go because 3 is prime. All right, so and also you can do this either way, because remember, you can turn it around this way or that way. It doesn't really matter. Now look at the gray box. Another approach. Since multiplication is distributive, we could have solved 1.5 times 1/4 using distribution. Distributing the multiplication to the whole number portion and the fractional portion. So 1/2 times 1/4 would be the same as 1 times 1/4 plus half times 1/4. 1/4 becomes 1/8 because you have to make them common, and then 2/8 becomes 1/8, and then you multiply that together, you get 3/8. I think it's a little bit confusing that way. To me, this is the best way. Just change. You never can multiply with a whole number there. You always, with multiplication, you always need to change those to improper fractions. So you just multiply across. Of course, sometimes you may have to simplify your problem here. Okay? And you may end up with a mixed number as your answer, and that's okay. If you come up here with an improper fraction, that may be the case. All right, now go ahead and look at worksheet 6.2. Okay, it says you can use your calculator here. Okay, now on number 1, you're going to be adding, subtracting, and multiplying these mixed numbers just like I've shown you here. Okay, you can always change them into improper if they're mixed, and then simplify down when you get your answer. Make sure you always get a simplified answer. Okay, there's some cooking ones there, miscellaneous there. There is a back page on this. Now, I'm not going to grade this page because this should not be new to you, but it might be because I don't frankly remember ever anything going into such detail. So I'm not going to grade it, but I do want to see it. If you have trouble, please let me know. I will be happy to go over it with you. Okay? That will conclude your lesson for the day.